Hello and welcome to another exciting episode of the 100 Days of Code, with me. And today we are going to be looking at another exciting topic that has to do with decimal, especially when you're working with systems that do with numbers. For most financial systems, this is something that you really need to pay attention to. And if you notice, most systems they already know this hack, which is something that it's not very very special to them because they are already applying to their system, but you're going to be learning it today. So when working with decimal, I'm going to show you something. So you have console log 0.1 plus 0.2. Now we already added to my JS to my index.js, and when we log this here, so you see that now we have 0.300000, and then there's a 4 at the back. So when we try to console log again, 0.1 plus 0.3 0.2 equal to 0.3, you see that this is going to give us false. And I believe you already know why this gives us false, even though technically this is supposed to evaluate to true. But because when the computer is evaluating decimals, it evaluates them as though they are binaries. So think about it like you are trying to perform an arithmetic division of 1 divided by 3, and then you get a lot of floats in, right? A lot of floating numbers. And that's basically how it works when you work with decimals. The fixed or the absolute numbers that you get in return are, or maybe like in 2 decimal places, depending on how many decimal places you want to use, and not the exact value of that number. So whenever you try to perform expressions like this, you are definitely going to run into bugs, and it becomes a great issue when you are building financial systems, because you would always have calculations where users have to pay things like $19.9, 19 point, maybe 20.5. So when you try adding up numbers like that, you eventually start running into problems, and before you know it, one two little 1 2 3, minor mistakes, they add up, and before you know it, they become like very very big, and the company is already losing a lot of money. So how do we fix this? There are two fixes to this. Number one, when working with numbers as decimals, right, what we can do, numbers as decimals, is to use what I call the tolerance. So we define a function and say is equal. I'll show you how this works. Is equal, and then we pass a, we pass b, and then we pass what I call tolerance. So tolerance is like saying this is what we can forgive. This is since the difference is so small, we are willing to let go of this because it may not really affect the system entirely. But this way you can make precise decision based on this level of tolerance. So you can say something like maths dot absolute. What maths dot absolute does is that it gives us the absolute number, either the positive or negative, right? So if we have -5 as a response, 5 becomes the absolute number. So here we want to minus a and b from a, so we're saying a minus b, and then we are now saying if when we get the difference between a minus b, we want to know if it is less than the tolerance level, and if it is less than the tolerance level, then it is actually equal. The both of them are equal, right? So we want to be able to check this, we want to say is this equal to, and then we can console log this and say is this equal. So since we use 0.1 and 0.2 here, we can check this and say is equal, and then we pass 0.1 and 0.2. So the tolerance for 0.1 and 0.2 would be 0.3, right? So we're trying to say the sum of both numbers should not exceed 0.3, right? The tolerance difference should not exceed 0.3. If it exceeds 0.3, then there's most likely going to be an issue. So when we run this now, you should see that we get a true. Why? Because we are willing to let go of that tiny difference. By the way, let me show you what that tiny difference actually is. When we console log math.abs and then we pass in a minus b, you should see that tiny difference. So this is the tiny difference. Let's console log it again. So this is the tiny difference, 0.1. That's on line 8, right? Yes, so the tiny difference is actually 0.1. So as long as 0.1 is less than 0.3, we are willing to let go of this, and then these numbers are actually equal. So this is one way to solve this issue. The number two way to solve this issue when we work with numbers as money is to use so for instance, using dollar as an example, instead of using the dollar value, use cents, right? And depending on the currency, always go for the lower currency. So for instance, let's say we have let me make a comment here. We have something like 19.9. Automatically this becomes 19.99. Let's say 19.99, because these are like real decimal values that we work with in real financial systems. So automatically this becomes 1999. So you convert cents to dollars, and this helps you manage calculations to ensure that your systems are really predictable. Or maybe you have things like, say, 12.52. This automatically becomes 1252, right? And when you want to convert it back from cents to dollar, all you just need to do is to say you have your cents dot you can see we can come here and see const actual figure equal to so let's assume this is our cent now. So let's assume we have a const cent equal to 1999, and then the actual figure automatically becomes cents divided by 100. So we can put this in brackets dot to fix, right, of 2, and automatically this gives us the actual figure in dollar. And then if we console log this, where are we getting require from? Oh, this is a mistake. So if we console log this, we should now see we get 19.99, and this is how it works. So we can now convert from cents back to dollar. But when you want to perform the actual arithmetic operation like addition, subtraction, just so that you don't have all of the decimal tiny floats causing issues, you just convert them straight to cents. And depending on the currency you are using, you can always go for a lower currency that doesn't work with decimals. Of course, lower currencies can also have decimals, but the possibility of having decimals are really low compared to the fact that these are like the lowest forms of possibilities, and you can ensure that your system is bug free. This does not entirely promise you that your system will be bug free, right, completely. Like, there will not be those tiny values that are missing, but this is just a much more predictable and easy way to handle it. I believe you learned something today. Thank you for joining me. If you did and you're yet to subscribe to my channel, do it to subscribe to my channel. Drop a comment if you learned something, like, share with your friends, and turn on the notifications so that you can always get notified whenever I drop a new video like this. Thank you, and see you tomorrow. Bye.